Welcome, we're team number 8 and we'll be presenting our gearbox design. Our team consists of Wright, with Sanchez, and myself, Kathleen Oyola. We're introducing our design with our proposed design with schematics and calculations, our cost estimate and maintenance of each material, and the estimate cost of what it's going to be for manufacturing, and it will be in conclusion with the overall design. The gearbox design has to follow specific requirements. It needs an input of 2.5 horsepower, input shaft speed of 1620 RPM, and an output shaft speed of 90 RPM. The components that we chose for this design are from the Boston catalog, and this design needs to be from medium to low precision applications, and as well have to be for in 90 to 95% of humidity. Some of the application for this design depends on our base. For example, in the low 2.5 horsepower, it can be implemented for simple mining operations or as well as a heavy equipment. And because it's a speed reducer, it can also be used for trend braking. For our literacy survey, we'll be showing our gears that we use. We use 4 spur gears and 2 bevel gears for 20 pressure degree angle, and the bevel gears to change the directions of the gears.
So as my partner said, we are going to have 4 spare gears and 2 bevel gears. Our first set is going to consist of 2 spare gears with a ratio of 3:1, because the teeth number is 120 and 40 for the pinion, turning at our input revolutions per minute, and the second one turning at 540 revolutions per minute. Both are made of cast iron. Our second set of gears are bevel gears made of hardened steel with a ratio of 2:1. Our pinion has 18 teeth and our gear has 36 teeth. The 36 teeth here is turning at 270 revolutions per minute. So our third set, finally, we have 2 spare gears. One is made of cast iron, that is going to be our gear, and our pinion is going to be made of steel with a ratio of 3:1, because the teeth number is 54 and 18. And finally, in our last set, we have a revolution of 90 revolutions per minute. So our proposed design, it starts here with our cast iron pinion of 40 teeth and our 120 gear. These are our 2 bevel gears, changing the angle to be perpendicular as our specifications. And finally, our last shaft. So this is an engineering drawing, just to see how everything is mounted. So our calculations for every year, we got the transmission load that they are going to suffer, and this is the allowable stress in PSI for every year. They are based on the material, cast iron, hardened steel, cast iron. So on these 2 calculations, the wear stress and the bending stress, we got those results thanks to all our constants. And as we can see, the numbers, the stresses are in the range of the allowable stress. They all are smaller than our allowable stress, making our system valid and efficient for our purposes.
So right here's a quick breakdown of our cost estimate for our gears. As you can see, our most expensive gear is just over $1,100, and that'll bring our total cost for our system up to $2,131. The price of the shafts is not that expensive compared to the gears, because there is a lot of precision there. Also, we had to use really wide gears for a large face to go and account for distributing all the stresses. If you look real quick at the maintenance, our maintenance includes service upgrades for upgrading the bearing systems, lubrication, things like that. It accounts for disassembly, lubricating the gears, making sure they're properly greased and alignment is there. And due to the pinion or the bevel gears, the pinion's going to end up failing after about a month. So with that happening, it gets into a caution area, and it should be taken apart to go and look and make sure that everything's safe. This is a quick simulation of our gears, which, as you can see, this one here is spinning extremely fast, but it does end up being a an 18-to-1 reduction, bringing our speed from 1,620 RPMs to, what was it, 90 RPMs for the output. This proposed design is valid for all these applications, including heavy machinery and mining equipment. Horsepower transmitted is 2.5 horsepower with the input velocity of 1,620 RPMs. The output velocity is 90 RPMs, and there's many different heavy-duty industrial applications that this system can be used for. Thank you very much and have a great day.